Fly along, that would be the aircraft up here, and this is how we're making the measurement all the way down to the ground. So this is as we fly along. We get a picture of the aerosols and a picture of the same thing with the ozone. So we can see how it's vertically distributed. And we repeat the pattern many times over the day. We can see how that's moving throughout the day.
Can you further explain in layman's term what would that apparatus do in order for us to improve the air quality in Asia?
Well, to understand air quality, you have to understand the dynamics of how aerosols and pollutants get transported throughout the day. It drives chemistry, it drives everything, and how the meteorology, the wind, everything carries it through. It also helps you identify point sources. Where are the pollutants coming from? So this information of being able to show where everything is and how it's moving gets rolled into the models to help improve, to increase that understanding.
72 model. It's like I said, it was built by Douglas Aircraft Company in 1968. Came off the line in Long Beach. We've been flying it since 1986. Prior to that, it was an airline with Alitalia and Marana Airlines back in the early days. And then obviously didn't come to us like this. We've done a lot of conversions and modifications to it since then. So.
What will be the importance of this plane on this mission?
What's that?
What is the importance of this plane on this mission?
We are flying this aircraft in conjunction with the Gulfstream next door. We're flying down low in the atmosphere between the surface to about 10,000 feet, and then the Gulfstream next door is flying high at about 28,000 feet. So we're down here, you see all the instruments as you walk in the back of the plane, and you see all the probes sticking out where, for lack of a better term, sniffing and smelling the atmosphere. Those probes are sampling air coming in and processing all that data down low where that pollution is residing in the greater local area here. So we're down low. We've done a lot of coordination with all the local airspace traffic controllers, and a lot of really important pre-coordination that allows us to do this safely, most importantly, and try to not disrupt all the air traffic in the local area as well. So it's a really exciting mission to do, partnering with the Gulfstream next door and all the local agencies here with PHLSA and DNR. It's been quite a group effort. Any other questions? Are you done?
So once they're all filled, we take them off, put them in boxes, and we ship them FedEx home to our laboratory in California. The canisters will be analyzed, and then they will be evacuated and conditioned and sent back to in this case, to Malaysia. And so we have 30 of these boxes of these canisters sets here in the Philippines. We have 32 in Korea, but we have none in Malaysia. And so we will hopefully get these analyzed and shipped to Malaysia. And then the ones that are collected or analyzed or collected in Korea will be analyzed and sent to Thailand. And so it's really a difficult experiment because if there's a problem with airplanes, if there's bad weather, these don't get shipped. And we only have 64 of them, and we need 127. And so we're always pretty stressed at the beginning of so we sent our first ones out yesterday. And but in them, we measure 100 different gases. And those gases are gases that can either be greenhouse gases or they can help form ozone in the troposphere, and which is a pollutant. And so what we're hoping is that in our flying, we will identify a gas or two or three that are greatly affecting ozone concentrations, and that maybe the government can put some regulations on those 2 or 3 gases, and it would help your ozone concentration. That's what we're hoping.
Okay.
Yeah.
Yeah, we are under the chemical circulation in the